Hello, PreCalculus. How are you doing today? Welcome back to class. Come on, let's go. I thank all of you for submitting that Google form yesterday. Um, 72 out of 75 ain't bad. You know what I'm saying? And I thought I'd go over the data real quick with you before I talk about what I would like for you to look at today, math-wise. How many of you guys miss math? Well, right in the middle. That makes sense. 34% were at a 3. One was what's math? And there were 9 responses there. 5 was I'm changing my name. Um, yeah, just call me Y equals MX plus B. So I thought that was pretty cool. There's actually a pretty high percent of you guys that sort of missed math. But right around the middle makes sense. Almost normal distribution if we bump that middle up a little more and brought the 5 down. Anyway, if I had to pick, I would have guessed sleep, and that's pretty much what we did. We slept. I know I took naps and I slept in. It was pretty nice to have 2 weeks of snow days, and then 1 week of spring break. So uh, video games, dank memes, social media distancing. 8% of you give wish you had homework, so I'm sorry about that. I should have given you more than I did. Sad face parabola. This was pretty good. 93.1% got this right. The x squared equals negative y. You divide the y over, and you'd have y equals negative x squared, right? Parabola that opens down, or sad face parabola. When we write them as conics, remember we in the conic section of a parabola, the conic form is we put the square part on the left, and then it equals everything on the right. And there's a 4p in front. 4p is the coefficient, and so that's that. That one was right. This one, not so right. For an ellipse, the x squared over 100 and the y squared over 64 uh, does mean the minor axis comes from the 64. So a lot of people, almost everybody, knew to look at the 64. You take the square root of 64, which is 8. And 8 was the most picked answer, but 8 was also wrong. Because what you then do is you double the 8. So 64 is b squared in the problem. You take the square root of that and you get 8, and then you times that by 2. So again, this was 3 weeks ago. We spent 3 days on ellipses, and the first day was graphing them and all those properties. Then we spent a couple of days doing that whole completing the square thing, which took a lot of time and it was really tough. And now it was like that didn't even matter because we're just going to keep on rolling. But probably won't worry about too many of those completing the square problems for the hyperbola. But anyway, the answer was 16. And so, oops, there, we need better teachers. Are you ready to finish the school year strong? 68, yeah, answers responded yes out of 72. That's what that 94.4 is. So there were 4 no's. Maybe the 4 no's actually read the whole sentence. Are you ready to finish the school year strong? And you're like, oh, no. And then the 68 yeses just read to the part, are you ready to finish? And thought, yeah, let's just get out of here. So we still have a little bit of time. Matter of fact, let's make that a lot of bit of time to get through this second semester, but we will do it. It's almost there. I'm telling you, it's going fast. Flying by. So what do we need to talk about now? I thought that what I should do is, oh my, Mirror 360 closed down. Really, bro? That was open earlier. Here we go. What you are going to do today, and you may have already read the assignment, but look, Mary and me. Um, lecture notes. You are going to graph the assignment that I gave you to do over the break. Some of you guys finished that, some of you guys didn't. And so maybe your thought was, well, I didn't do it because I really forgot how to do graphs of ellipses. And so that's why I want to kind of review that with us right now. Maybe you didn't do it because you're like, this doesn't really count, okay? Like, technically these are snow days. So you're right, those were snow days and you didn't have to do it. It was an experiment. And there were not very many responses turned in. So that's why you're going to do it today, because today it counts. So x squared, whoops, I'm gonna go back to a different color. X squared over 4 plus y squared over 1 equals 1. That is an ellipse, right? It's got this form here. The center of the ellipse comes from the HK, right? So in this case, the center would be 0, 0 because it's x minus 0, so h is 0, and y minus 0 is y squared. Y is 0. So the center is 0, 0. But then what we do is we take the 4 and the 1, and you first have to figure out which one's bigger, because that number is a. 4 is bigger than 1. So since 4 is bigger than 1, that tells you that a squared is 4, which means a is 2. So from the center, you will then travel horizontally, because since a is with the x, since 4 is a squared, and a is with x, that means your major axis is 2 to the left and 2 to the right. So that number 2 that we got for a is here, a and a. And now the 1 is the smaller number. I think I'm gonna go this way with the 1. B squared is 1. If b squared is 1, b is 1. So from the center, you go up 1 and you go down 1. That distance is b. So there's your ellipse. Try that again. There's your ellipse. Notice the minor axis. The minor axis of the ellipse is 2. Pick a different color. Come on, Marty. Tackle. 2. See the purple line? Because it's 1 up and 1 down. So the minor axis has a length of 2 times b. The major axis has a length of 2 times a. So 2 times 2 would be 4. You can count 1, 2, 3, 4. You count up and down 1, 2. So the mistake on that Google form, a lot of people took the square root of 64 and got 8. But then you would multiply 8 times 2. Because 8 is 8 up and it's 8 down. So you'd have 8 plus 8, which is 16. Okay. As Gloria Estefan would say, turn the ellipse around. If it's x squared plus 4 over, let me actually change that. X minus 3 squared over 4 plus y plus, say, 5 squared over 16. We've changed the value of a now, right? See, the bigger number is 16. 16 has to be a. A is always greater than b. So in this case, that's an arrow. A squared is 16. A is 4. B squared is 4. B is 2. And the center, right now, this green dot, the center is 3 comma negative 5, because it's always x minus h and x minus k. So since it's y plus 5, that means k is negative 5. So the center of this particular ellipse is 1, 2, 3, 1, 2, 3, 4, 5 down. And then how much does it go up? It goes up. I'm gonna switch back to blue, right? See, it goes up 1, 2, 3, 4 now, and down 1, 2, 3, 4. Because since the 4 is a, and a, the bigger number, 16, a squared, right? The bigger number is with y. So that affects the vertical change. The major axis is vertical. The major axis is vertical because the bigger number is with y. And then b is 2. So from the center, you go over 2 to the left, over 2 to the right. So this ellipse, it opens, or it doesn't open, it's orientated up and down, right? The major axis is vertical. Notice the minor axis would have a length of 4, and 4 is 2 times 2, right? So it's always 2 times the b for the minor axis, always 2 times b. The major axis is always 2 times a. So this bunnies activity, where's the bunnies? Here's the bunnies. You have a bunch of ellipses and some circles, and then a couple parabolas and the sine curve. But maybe you were confused on how to graph all these ellipses. Most of them were ellipses. So hopefully this helps you remember. And at this point, pretty much finished. There was a sine curve in there. That's kind of tricky in case you forgot. And it does say in radians. The radians is important because when you graph a sine curve, let's pick a new equation like y equals the sine of x. And let's go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 right here, minus 11. Okay, on the worksheet, it's minus 15. So I'm going to go down 4 more, but I don't have that space here on this grid. So the sine function now, it basically just goes up to 1 and back down to 0, and then down to -1 and back up to 0. Now, where does it do that? Because these points kind of matter. When you use 1 radian, like this is 1, 2, 3 radians, and notice the x-axis is just, or the x-intercept is a little bit past 3. That's because the sine of pi is 0, right? And so you should be back to that -11 at pi. So if I go 123.14, right? Which the day after I saw you guys last was Pi Day. Hope you had a nice Pi Day. I completely forgot it was Pi Day until like that afternoon. Somebody posted on my Facebook like "Happy Pi Day, Mr. Quirk," and I was like, "Oh yeah, it's Pi Day." And then a few of you guys commented on my Google Classroom, which I noticed later that it was Pi Day. So thanks, homies. Hopefully next year we can have Pi Day. We won't have Coronavirus Day next year. We're gonna have Pi Day. So the sine graph is basically just repeats, like this. You can type it in the calculator and trace it. Okay, put it in radians and trace 1, 2, 3, 4. So 1, 2, 3, 4, 5, 6, 7, 8. Just plot the dots that you get. It's pretty much going to look something like that. It's supposed to sort of snake across the bottom of your graph. Okay. So this graph I want you to do today. You're going to take a picture of your graph paper and submit it to Google Classroom. If you already did that, then you don't have to do it again. If you want to submit it again, the same picture, you can, but I still have the other ones saved, so it's all good either way. But I do want you to do it because this is where we're at. Some of you guys, your graphs were a little bit off. So if you just had a friend text you a picture of their answer, and then you just like kind of copied it and sort of didn't have the graphs in the right place, then it's wrong. So do it again. Also wanted you to color it. A few people didn't color it. I guess you got to 12 and thought you were done. See how it says 13, color it. And then the bottom, it's like, oh yeah, that was the last one. Never mind. I thought I had another message at the bottom. So this is your homework for today. Something worth mentioning, since it happens to be right here, is the calendar that we're going to use at Eastern for the rest of the year. This week is kind of like just getting back to know you, and I hope you're all right, yada, yada, yada. But next week, we're going to start a more structured plan where students and teachers have opportunities to meet. So you see the schedule here where first period and fifth period will actually meet on Monday, every Monday, at 9:30 for first period. So that's my first period pre-cal. Let me hear you. Woo, first period. Woo. 9:30. You'll meet your fifth period at 12:30. Okay. After lunch this time instead of before lunch. Isn't that crazy? Wiggity wiggity whack. Second period pre-cal. Let me hear you. Woo. We'll meet on Tuesdays at 9:30. Tuesday at 12:30 is sixth period. Wednesday's a catch-up day, so there's no like Google Meets on that day, unless the teacher, I guess, wants to. Thursday's third period, 9:30, which is my planning, so I get to sleep until like 10:30 every day on Thursdays now, I guess. Except the school's asked us to sign in by 7:30 every day. We have to wake up and fill out a Google form before 7:30, so that's kind of fun. Seventh period on Thursdays, and then Friday I'll have my fourth period. Let me hear your fourth period pre-cal. Woo! Fourth period pre-cal, we will meet on Fridays, every Friday, 9:30, Google Meets. And I'll set all that up and send out the information about Google Meets, later. But that was just shared with us, last night. Like, hey, this is how it's going to go. Where are we at? Here we go. This is where we're at. So before I hit stop here, we're almost 15 minutes. I thought I might say hello and goodbye. And thanks for being here. This is bizarre that we're doing school like this. I know it it's kind of ironic because usually every year people come back from spring break and like, I don't want to come to school. This sucks. I want to go on spring break. I want to go to the edge. I just want to quit school. And I would imagine there's a little bit, maybe one or two people anyway, today were like, I wish we were in school instead of doing this. Um, it is my opinion that this is the way the year is going to end. I don't think we're going to go back to school, but I could be wrong. I've been wrong like a bunch of times. But that just seems to be the way things are happening now. Um, so thanks for being here. We do have a lot of stuff to cover. We're still going to get through limits and derivatives because the purpose of this class is to prepare you for BC Calculus for next year, which is going to happen next year, right? BC Calculus. So um, I'm going to keep pressing forward. I'm going to make some videos. We can do some live Google Live casts where I can even teach lessons live. Um, but I'll probably make just a lot of videos for each day for you to take notes and then practice the work. And then we'll have the live sessions where you can answer questions and stuff. You can always email me too. But we've got a lot of math to get through to get you ready for, next year. So it's good to look at you. Take care. I'll see you soon. Bye.